Okay, welcome back to 6.4, the second part of adding and subtracting rational expressions. We are now going to add and subtract with either binomial or trinomial denominators. Last time we were adding and subtracting monomial denominators, and that's what these two warm-up questions are. So I'm going to let you do these two first before we start the binomial and trinomial denominators. Okay, so these two are done like these. Okay, so this should be your answer, 3x plus 2 over x squared. Again, here is x squared, and that's x. So the common denominator would be x squared. Therefore, we need to multiply the second fraction by x. And then just need to expand. You get 3x plus 2 over x squared. For the second one here, your common denominator for 3 and 5 would be 15. And you have x and x squared, so you need an x squared to be the common denominator. Both have y and one single y, so then we just leave it like that. So for the first fraction, you got to multiply by 5x. For the second fraction, you just need to multiply by 3. So because it's a minus sign here, so be careful. When you multiply, it's negative 3 times x, so it's negative 3x. It's negative 3 times positive 8, so it's negative 24. Combine like terms together, and that's what you should get. Real restrictions. It will be x cannot equal to 0, and x cannot equal to 0, and y cannot equal to 0 for part B. Okay, so these two are for monomial denominator. Okay, so one single term. We are now going to look at some binomial denominators and trinomial denominators. So these are binomials, right? Two terms. And next page, you'll see some trinomials. Okay, but regardless of what kind of polynomials that you see, the very first step is, once again, not a surprise, factor. Okay, you must factor if possible. Okay, it's not just the denominator, it's also the numerator, right? You just factor anything you can. Okay, always factor. Okay, so now this is a common mistake because I guess we're used to deal with x and numbers separately. So now when you see binomials, you might think, okay, so then I have x and x here, so then my denominator will be x. That's a 2, that's a 3, so maybe it's minus 6. Okay, maybe you're thinking it that way. Unfortunately, that's not how it works. Okay, it doesn't work that way because you can't multiply x minus 2 to x minus 6. If you multiply by 3, you actually get 3x minus 6, not just x minus 6. Okay, so it doesn't work that way. When you have binomials, what you need to have for your common denominator is you need the whole thing, okay, x minus 2 and x plus 3, because you can multiply actually the first fraction by x plus 3 with the 2x that you already have. Okay, and the second term, again, the common denominator is going to be x minus 2 times x plus 3. We already had x plus 3, so all you needed to multiply is x minus 2 with the 3x minus 1 that we already had. Okay, and now we need to expand this. This is x times 2x, that's 2x squared. 3 times 2x is 6x, plus x times 3x is 3x squared. X times negative 1 is minus x. Negative 2 times 3x is negative 6x. Negative 2 times negative 1 is a plus 2 over one single fraction now, right? Or yeah, you just need one single fraction now. Okay, over x minus 2 times x plus 3. Collect like terms. 2x squared plus 3x squared is 5x squared. That's 6x minus 6x, so that's negative x. And you still have the plus 2 at the end. And your denominator does not change. I wouldn't recommend you to expand the denominator. In fact, you should actually try to factor the numerator if possible. Okay, obviously not every single time you will be able to factor, but sometimes it's factorable. And once you factored it, sometimes you can actually reduce what's happened, the numerator and the denominator. Sometimes, okay, not always, but it does happen sometimes. So you always try to factor if possible, even at the last stage. And if you cannot factor this anymore, I wouldn't even worry about expanding it. I would just leave it like this as your final answer. And your restrictions then would be, well, here x cannot equal to 2, and here x cannot equal to negative 3. Okay, so these are your restrictions. Okay, so that's part A. I'll let you try part B yourself, okay? So again, the very first step is to factor if possible. Okay, good luck. All right, for part B, you can see this is factorable. This is 4 minus x squared. This can be factored. This is a difference of squares. So 2 minus x times 2 plus x. 3x minus 1 remains. You still have the x minus 2 here. Now, okay, you know what, I'm gonna write this down first. Okay, so these two are similar, right? That's 2 minus x and that's x minus 2. They're not exactly the same, but they are just negative sign away from each other. So what I can do is I can turn this into x minus 2 by factoring negative 1 out. So if you factor negative 1 out, this actually is the same as 2 minus x. Now, I don't want to leave the negative sign in the denominator because makes things more complicated. So what I'm going to do is I'm actually going to put this negative sign on the top, okay, in the numerator. So instead of 3x minus 1, I'm going to write this as 1 minus 3x. And then I don't need this negative sign anymore. Okay, so notice how it was negative sign, and I simply flipped these two signs. So it becomes negative 1 becomes positive 1. Positive 3x becomes negative 3x. If I do that, then I don't need this negative sign anymore. Okay, and I still have the 2 plus x minus. Now, if you want a common denominator, since this has x minus 2 already, we also have x minus 2 here. But what we are missing here is this 2 plus x. So what I need is I need to multiply this side by 2 plus x. Or you can write it as x plus 2 as well, right? It's your preference, doesn't matter. I usually write it as x plus 2, as you should as well, right? Always write the variable first. So I'm going to change that. This is x minus 2, and that's x plus 2. 1 minus 3x remains. Okay, again, we can write it as one single fraction, so I'll write it in the middle. X minus 2, x plus 2. Now we need to multiply, that's negative. Okay, so we have 2 times 3, which is 6, but it's negative 6. We have x times 3, which is positive 3x, but it's minus 3x, so it's minus 3x here. Now we can combine like terms. Negative 3x minus 3x is negative 6x. 1 minus 6 is negative 5. You still have the x minus 2 and x plus 2 here in the denominator. And your non-permissible values will be x cannot equal to plus minus 2. Okay, because those two values will make your denominator 0. All right, hopefully this wasn't too bad for you. But again, the very first step is to look for the common, to factor. Always factor first, and then find a common denominator. Okay. Okay, so here are 2 questions. I'll show you the first one, and let you try part B. Okay, so again, we can factor this. This actually can be rewritten as x squared minus 49. So that is just, again, difference of square. That's x minus 7 times x plus 7 plus. This can be factored. This is x plus 7 times x plus 3. Okay, now if you're looking for the common denominator, you can see both terms have x plus 7. So that has to be there. Since it's good because you already have it. X minus 7 is here, so we will need that as well. But we have this x plus 3 that's missing on the left hand side, so we still need that because otherwise we cannot have common factor, right? Because we do have it on the right. So you need to make sure you have everything. So now you can see we have x plus 7 here. Right? X minus 7 here, x plus 3 here. So I cover everything for the denominator. So this will be our common denominator. You don't need to have the square for the x plus 7 because all you need is 1, right? You don't need 2 of them. Since each fraction only has 1 of them as well. Okay, so now same thing. We already have x plus 7, x plus 3, but we are missing x minus 7, and that's what we need to multiply by. Okay. So now we just need to expand. This is going to be 3x plus 9 plus 5 times x is 5x. 5 times negative 7 is negative 35. All over x plus 7, x minus 7 times x plus 3. Collect like terms. You have 3 plus 5 is 8x. 9 minus 35 is negative 26. And you still have x plus 7, x minus 7, and x plus 3. Notice this is factorable, so I would factor that. I can divide everything by 2. And this is what I get for my final answer. Unfortunately, I cannot reduce anymore, but that's okay. This will be our final answer. Okay, and as for the non-permissible values, I have a little room left here. X cannot equal to plus minus 7 because of these two, right? 7 and negative 7 will make those two 0, and negative 3. Okay, so factor first if possible. Okay, always factor first, and then look for your common denominator. Okay, part B, good luck. All right, so I don't know what happened here. This should have been 14, not just 1. Okay, yeah, something went wrong. That's okay. If you factor this, you should get x minus 7, x plus 2, and it should be x plus 2 times x plus 2. So if you're looking for the common denominator, it's going to be x minus 7, because you have 1 here, x plus 2, because you have 1 here. Now on the right second fraction, you have 2 x plus 2's. Therefore, your common denominator is actually going to be x plus 2 squared. Okay, one of them is not going to be enough because you already have 2 here. You can't just say, I'm going to get rid of 1. You can't do that. Okay, so you actually need x minus 7 and x plus 2 squared for your common denominator, which means for the first fraction, I need to multiply by x plus 2. For the second fraction, you need to multiply by x minus 7. You just need to expand. Let me just quickly check my work. Looks fine. X squared minus 9 looks okay. Be careful because it's a minus sign. Okay, so I would actually write everything in brackets for each expansion. Okay, you can see I put this in brackets right here, and I put this in bracket as well. Okay, I would always do it like that, especially when it's a minus sign. Okay, because it could lead to mistakes if you don't. Okay. That's what you get after you simplify them. Now, I don't think this is factorable, so then you leave it like that. Again, this sometimes is factorable. It's actually very difficult to make a question that is factorable here, but it does happen sometimes. So you need to make sure you check that this, whether this could be factorable or not. Okay, check whether it could be factored. Always, okay? Because sometimes you could actually factor and then you can actually reduce. All right, for non-permissible values, you'll be the 7 there and the negative 2 right there, okay? All right, last example, we have some more problems, and ultimately we actually will do these a lot, the last section, okay? Anyways, we can start thinking about it. We're not solving yet, we're just writing expressions. Okay, it says on a canoe trip, Peter paddled upstream a distance of 10 kilometers. On a return trip downstream, the average speed of the canoe was 5 kilometers per hour greater than its speed upstream. Makes sense because you're going down the stream, so you're going with with water, with current, so you're going faster. Write and then simplify an expression for Peter's total paddling time in terms of the average speed upstream. Okay, so there are a couple of things that you need to know here. First of all, we need to define the variable. It says this is the variable that we want to use, average speed upstream. So I'm going to say let x be the average speed upstream. Okay, so that's my variable. Upstream. Now the second thing you need to know is the relationship between distance, time, and speed. Okay, the easiest one that I always keep in mind is speed, because speed, this is equal to distance divided by time. Okay, I know this for sure because I always think about kilometers per hour. Kilometers, this is a speed, right? This is a speed. Kilometers per hour is a speed. Kilometer is distance. Hour is time. So kilometers per hour is distance divided by time, and this gives you speed. So this is the equation that I always work with first. but it might not be the one we are using, okay? So let's see. It says we're looking for an expression for total time. We're looking for time, okay? So here I start with this, and now I need to solve for t because we're looking for time. So this means I can multiply both sides by t. I get st, street, is equal to d. And then I can solve for t by dividing by s. So t is simply equal to distance divided by speed. So this is the equation I'm going to use for this question, okay? Now, total time. Total time means time going up plus time going, I should just use the lowercase, time going up plus the time going down the stream, right? So that's the total. Okay, so I need to come up with the expression for each one of those. Now I do know the distance is 10 kilometers. So time going up is going to be the distance going up, which is 10 kilometers, divided by the speed going up. And we just said that x is the speed going upstream, so 10 over x, plus the distance going down the stream is still the 10, right? I mean, it doesn't matter if you're going up and down. If you go up by 10, that means you're on the way back down. It's also 10 kilometers. Now, what's the speed going down, though? It says the average speed was 5 kilometers per hour greater than the speed upstream. So instead of just x, it's going to be x plus 5. And this is the total time. Okay, this is t total. So this is the expression, and now we just need to simplify it. So now we need to get the common denominator. Again, this is a binomial, so you cannot simply say that, okay, so then I guess x plus 5 is my common denominator. You can't multiply x to get to x plus 5. It doesn't work that way, okay? Anytime you see a binomial or a trinomial or even greater polynomials, you need to factor first. There's nothing you can factor. But then that means the common denominator is going to be x times x plus 5, okay? You need to multiply both, because you can actually multiply x with x plus 5 to get to this, right? So this is our common denominator. This 10 looks like 16. There we go. You can multiply x with x plus 5 to get your common denominator, so we just need to multiply 10 by x. Okay, so then you can simplify this. X times 10 is 10x, 5 times 10 is 50, 10 times x is 10x, so you get 20x plus 50 over x times x plus 5. You can factor this, you can factor out the 10, and you get 2x plus 5 over x times x plus 5. Again, you cannot reduce anything, but that's okay. This then would be your final answer. And your restriction would be x cannot equal to 0 and -5. Okay, so that's it for this lesson. Hopefully you understand what I did here. Again, I don't, but I think this could be helpful. S is equal to d over t because speed, and you get a unit for speed, meters per second, kilometers per hour. That simply tells us it's distance divided by time. And from there, we can solve for any variable that we need. That we needed for the question, right? I just solved for d right here. Distance would be speed times time, and time would be distance divided by speed. So these three, really just pick one to remember, then you can manipulate and then get the other two. Okay, so that's it. That's it for 6.4. Next lesson, we're actually going to start solving equations. Okay, do some practice, and then let me know if you need help.